Hello everyone and welcome back to this next lecture. So in this lecture I'm going to give you some tips on how best to complete this course. So a few of these will be quite obvious and a few of these will be very specific to this particular course, and therefore I would recommend that you watch this video. So the first and foremost thing with any online course is to, of course, try and watch all the videos at least once, right? Try not to skip any videos, try to watch all the videos. And in some cases where there is a little bit of complexity, go ahead and try to even watch the videos more than once, right? So this could be where certain setup is done or where certain kind of theory have been described. You might have to watch the videos more than once. But please do try to watch all the videos at least once. The second is, do not just watch the videos. Later on, as the course progresses, I will be having coding along sessions, which means I will be doing projects, and I will also be showing how the kit, how these connections can be made to the kit, and how you can actually have the oscilloscope connected to your development kit and measure signals on the different pins of your development kit. But for all that, you must be prepared with an entire development environment. For that, please download and install Code Composer Studio, and I will show you this in the next section, how we can download and how we can install it, and also how you can install the C2000ware software. All this comes from Texas Instruments. Now, if you have you have taken my previous course with the F28069, in that I had used the Code Composer Studio version number 12. Now the latest Code Composer Studio version 20, at least at the time of making this video, has significantly changed. And some of the features of the IDE will be highlighted because some of it has changed quite a lot, right? Many of the changes are unfortunately not very nice, but some of the changes have actually improved things quite a bit. The next is, please download all the documentation for the microcontroller. That is the technical reference document, the data sheet, and also the kit starter guide. And all this can be found on the Texas Instruments website. And I will show you all that in the next section where we get set up with our microcontroller. Now, besides all this documentation, Texas Instruments also provides a number of application notes. So these application notes are on various topics. For example, how would you configure the PWM port for a motor control application? So some of these application notes actually provide some very interesting examples and also share some details about the code and also about the entire system itself, which can be very, very interesting and also a good learning experience. So now it's important to remember that this is a very long course, right? I have provided a great amount of detail, both of the microcontroller and also the peripherals, right? So this isn't a course where you can just kind of skim through the videos and get some kind of an idea. This is a hands-on course. I will be going into great detail, both in theory and also in developing projects. So there will be a lot of projects where I'll be creating the projects, I'll be writing code, and finally I'll be verifying it on my development kit, which I have with me. So all this will be done in this course. So be patient and also spend some time on doing all the exercises and going through all the theory lectures, like I said before. Now the reference documentation for this particular microcontroller is very long. It's more than 2000 pages. Of course, given the fact that we are not going to be talking about all the peripherals, we might be dealing with only around 1000 pages. But I would show you how to reference it and how to use it as a quick access guide. And I would suggest that also spend some time reading the technical reference documentation. And just to be warned, this is not a very easy document to read, right? So it is quite tough to read. You might have to read it several times, but please, this reference documentation is a great wealth in terms of knowledge. So you can have, just about everything of this microcontroller is provided in the technical reference documentation, and therefore there is almost nothing that is not provided here. You just have to know how to access it. At the same time, I will also show you how you can import the example projects and how you can read the code in these projects, how you can interpret the header files, how you can search for configurations, and all other things which are provided by Texas Instruments. Because these projects are sometimes not that easy to understand. There are various different types of files, there are very different types of folders, and therefore it takes a while to actually get your bearings around a project from Texas Instruments. Now, with respect to programming the microcontroller, there are now two approaches. And this is something which even my Texas Instruments has proposed itself. The first approach is called driverlib. And in driverlib basically contains a whole lot of functions. This is similar to like an API library. An API library where the user has all these different helper functions and predefined constants. So if you want to program the microcontroller or any of the peripherals, all you have to do is just call all these helper functions and use the predefined constants. You do not really have to deal with the registers. That is one of the advantages of driverlib. Now I will show you how certain functions can be used, but at the same time I will also show you how with driverlib you can still access all the registers and still make configurations if you so choose to. Right? So this is driverlib is more about, if you take any of the other courses such as microchip, or for that matter my course by STM32, you will find that all these manufacturers provide similar API libraries. And Texas Instruments is also trying to come up with something which is similar to those API libraries, and they have called it driverlib. The other approach, and this is something which I've used in the past, is called bitfield. The bitfield approach is where each and every configuration register has been represented as a C structure. And now you can actually manipulate each and every group of bits in each and every register by merely changing the elements of these C structures. And this is something I will show you very soon when we start programming. And if you've already done my F28069 course, you would already know how this works. So in this course, both approaches will be used, right? So typically, as I said, in this course, since we have a dual CPU processor, we will be programming both processors. So throughout this course, I will be using one approach for one processor and the other approach for the other processor. And I will be switching back and forth. So for example, in one particular example, I may use driverlib for CPU 1 and bitfield for CPU 2. And in the next example, I will switch and I will use bitfield approach for CPU 1 and the driverlib approach for CPU 2. So in this way, you will get practice with both types of approaches, because you never know what your company will use. You may be working for a company which uses the driverlib approach, or you may be working for a company which uses the bitfield approach. And therefore, it will be wise that you be comfortable with both approaches. So in this course, every now, we are going to be looking at circuits. We are going to be looking at timing diagrams. We are going to be looking at waveforms and several other things. So once in a while, I will ask you to pause the video and go ahead and draw some timing diagrams or check things out on your own, right? So there'll be a few challenges every now and then. So whenever I do provide such a challenge, please pause the video and see if you can figure this out on your own. In the beginning, it might seem a little hard, but as time goes on and as you get more comfortable with the course, I would strongly suggest that you try out these challenges on your own, as this will give you more confidence with microcontroller programming. So in the beginning, while you start this course, do not use any of the code to immediately start controlling power converters. While you are doing this course, please use only the kit and the oscilloscope. Measure the waveforms that you generate on the oscilloscope, but do not use them to actually regulate a power converter. As this course progresses, we will gradually work towards a practical example. Only after you complete the course should you try real projects. Do not try real projects just after maybe finishing the first one or two sections, right? The reason is simple. Power converters need a great amount of detail in order to be able to control them. And if you do things in a half-hearted manner, you may damage your power converters. Towards once you complete this course, you will see that we have completed a fair amount of detail, and now you'll have the confidence to actually work on power converter projects. But in the beginning and while you're doing this course, do not straight away start using the examples to control power converters. Use this course only while you're doing this course, only learn by observing the waveforms on an oscilloscope. Now, if you ever have any doubts or you get stuck with anything, use the Q&A forum on Udemy. I try to answer questions within a few hours. Now, there are people who try to reach out to me in various other forms. They send me emails, they send me messages on social media. Sometimes I do answer, but sometimes they just slip by, they move into my junk folder, or sometimes I just can't respond because I get so many messages for various other reasons. So therefore, if you do send an email to me or send me a message on social media, I can't guarantee a response. But if you use the Q&A forum, I try my best to make sure that every question is answered within a few hours at most. Now, the best use of this Q&A forum is for the content of this course. So if you have any doubts about the course lectures or any of the examples that I tried out, by all means, post in the Q&A forum. But besides this, you are always welcome to start any discussion on any topic in power engineering. If it is not a part of this course, I may not be directly able to answer you. I may just refer you to other resources, right? But still, you are very welcome to start any topic in power engineering. So this is a brief idea of how you can complete this course. As I said before, some of it is pretty obvious, but some of it is very specific to this course. So I do hope you have some amount of clarity on how you can complete this course. If you have any more doubts, please post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture. Thank you so much for listening and see you soon. Goodbye for now.